All right, this is part 2 of analyzing graphs of cubic functions. We are on example 3. Graph f of x. Identify the x-intercepts and the points where the local maximum and the local minimum occur. Determine the intervals for which the function is increasing or decreasing. All right, so you can see I already put down here so we don't miss anything. We're supposed to find the x-intercepts, the local maximum, the local minimum, where it's increasing and decreasing. So let's graph the function first. We're going to use our TI-84 to graph this. So if you go to y equals, and we're going to graph x cubed minus 3x squared plus 6. And if we hit graph, it looks like the y-axis is still off a little bit. Let's zoom 6, which takes us back to a standard 10 by 10 window. You can go to window and just change it manually, but if you hit zoom 6, it will zoom in and make this a normal 10 by 10. All right, so first thing we need to do is find the x-intercept. We can see that it's going to have one x-intercept right in here. So, well, let's see. It says to graph. Let's go ahead and take a screenshot and put our graph down. All right, so you can see I put the screenshot there. It will not let me record and make a screenshot at the same time. So I just took a screenshot of the window. So we have graphed the function. Now we need to find the x-intercept. So if I go to second trace, which is calculate, I need to find the 0. Remember, the x-intercept and 0 are equivalent, two different names for the same thing. So come down here, and I'm going to hit enter for number 2. And then see where it says left bound, so I need to be left of this point. You can see it's barely right of that point, so I need to scroll to where the cursor is below that point, which is left of that point. Hit enter. Then I'm going to scroll above it, and I need to be to the right of it. So see, the 0 is here. That is a little bit to the right of it, so that will work. Hit enter. It zooms in. You can see it's kind of looking between these two arrows here. And then we hit enter one more time. You do have to hit enter twice, and it gives you that 0. So that 0 is going to be negative 1.195823. So let's go ahead and put that down here. Negative 1.195823. And I put equivalent to that may be rounded a little bit, but if you want to round it a little bit closer to the decimal point, you don't have to have that many numbers out through there. But now we need a local maximum, which looks like it's going to be right there on the y-axis. So let's do second trace. The maximum is number 4, so we're going to do number 4. And we're going to do the same thing. We got to be left of the maximum. Hit enter. Go to the other side of it. Hit enter again. Hit enter one more time. And see how it says x equals 1.7259e to the negative 6? That means this is in scientific notation. So that means there's like, you would move this decimal 6 places over and add 0. So basically this is 0, 6, which makes sense because if you go to 0 up 6, that would be your y-intercept. So our local maximum, we're just going to put 0, 6. And then we're going to find the local minimum the same way. Now, if you don't see that E there, you won't know that that's in scientific notation. So don't put 1.7. 1.7, remember, is like over here between 1 and 2. So that really is just very close to 0. So that's 0, 6. All right, local minimum is going to be down here. So let's do second trace. 3 is our minimum. So we're going to have to go to the left of the minimum, and then we're going to go to the right of the minimum. Again, remember, this is the local minimum. So those arrows there will zoom in here. It is a guess. And then it says minimum is going to be about x equals 2 and 2. So you can see x over 2 up 2, that does look like 2, 2. So we're going to put our local minimum is 2, 2. And then we need to know where it is increasing and decreasing. So we can tell it's going up here, so it's increasing, it's decreasing, and increasing. So we're going to define this based on the domain. So it's going from negative infinity to 0. And then it's decreasing from here to here. So that's going to be from 0 to 2. So it's decreasing from 0 to 2. And then it's going to be increasing again after that point. So from 2 to infinity. All right, let's check and make sure we've done everything. So it says to graph it. We did graph it. Identify the x-intercepts and the points where the local maximum and local minimums occur. We did that. Determine the intervals for which the function is increasing or decreasing, and we have done that as well. So that's all for example 3. If you have any questions, please let me know.